Hi guys, today we have Codeforces round 696 for Div 2, and earlier today I thought I want to practice a little bit, and I had no clear idea like what to practice, because like obviously I know several topics that I'm like a little bit weak at, so I could practice them, but manual selection problems from the problem set was a bit long, so I decided to go for difference instead. So if you join Anand's Discord server, there is a great bot TLU, and it can recommend you problems based on your rating, difficulty, and I think that it takes into account types of problems that you solved. So it will be more inclined to recommend problems from topics that you're not particularly good at. And later this week, we'll add the same bot to our Discord server. If you don't know, then we launched Discord server like on the weekends. There are already 46 people, I believe, and more will join soon. Obviously, like once we have everything set up, it will be just as great as an ANT server. But obviously, I also suggest joining an ANT server because it's by no means worse. Okay. Also, you can chat with an ANT there, right? So, yeah. So we have a scoring distribution that sounds a little bit like we can do first 5 problems like within limited time. We clearly can do first 5 problems, and the question is whether or not we'll be able to solve all of them like in 2 hours. So that's what we aim for today. Speaking of our friends who registered, have a couple of friends from Ukraine. Also, I just added Galen and David to friends just to track their progress, you know. Having friends who are better rated than you is always good. You can compare with them, you can learn a lot from their submissions. So that's why I added them as well. Yeah, so fortunately no unrated friends of mine participate. I mean, no rated, right? We are all out of competition. But it's still like, usually it's very educational. If you can't, like, Div 2 problems typically end at like 2500 difficulty. And on Codeforces, problem difficulty means that people with this rating solve it 50% of the time. So not 100% of the time, but like 50% of the time. And basically means like not every grandmaster can solve everything in Div 2 round. So yeah, and until you can solve everything, it's obviously makes sense to practice, right? So at least until we get 2500, we'll be solving all the 2 rounds. Yeah, and it will start very soon, so I prepared a little bit this time. So yeah, we'll see how it goes. But obviously we are here for interesting problems and training. Ok. Yeah, let me open all problems initially. Also, we can open submit straight away. Yeah, and here we see like all the problems on the same page, which is very convenient. Puzzle from the future. In the next year, Mike found 2 binary integers A and B of length n. Okay. The number of, okay. We can first start with like reading input. I hope I'm not, okay, I have string included. So we have two binary strings. We want to construct binary string D in the following way. C is bitwise sum of A and B without transfer and carry. Bitwise sum without transfer and carry is called XOR, whatever. Oh no. Ah, okay, I see. It's not XOR. Okay. Okay. So the D will be maximum possible as integer. Well, okay, it's very not nice problem. Okay. Yeah. Honestly, so we have a binary string B and we want to maximize D. And the problem, like why we can't simply add everything, like set all bits in A, is because we drop digits. So supposedly the best way is when all digits will be different, all pairs of consecutive digits will be different. Like it's just I don't want to implement it. There will be something wrong. I feel like it. Okay, so if the current digit is 0, we want to maximize, right? So first digit we obviously put 1 for A. Actually, it does not match, right? If A is empty, then we can simply add 1. I'm not entirely sure. Yeah, I suppose we have to do it like this, unfortunately. Okay, if the current is 0, can we use, is there a back method like in the string? It should be. Sounds like there is a back symbol. Okay. Actually, is this what I want or it's not? I don't understand. Yeah, that's why I don't like it, like, honestly. Yeah. And is at least once, so we don't have to think about this. This is not what we came here for. I must be like terribly bad at this point. Just typing everything like that. I have no better idea. Like if I start to think, something will obviously go wrong. That's why I have to avoid thinking and just bash it. So here previous symbols are 0, 0, and our current symbol is 0, which means that 8 plus equals 1. Here we have, okay, here we have current symbol is 0. Here it's 1. I don't know what I wrote it, I guess. So previous symbol is 1, current is 0, so we have current is 0, so we have to add 0. Here both previous are 1, so the sum is 2, so we can add 1. Here current symbol is 1, both previous are 0, so we can safely add 1. Previous is 1, current is 1, so we can add 1 more. Here it sounds like 0. Okay. 1, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1. Okay. Man, I don't know. It sounds legit, more or less. It's really not nice. Like, we just use greedy. I hope we did not do like any stupid mistakes here, but I'm not sure. Okay. Actually, I would like to see submit still. Okay, so we just use greedy and put whatever is like different from the previous, because obviously the longer number is the bigger it is, and then we just maximize the current digit. So we avoid having several digits that are the same. Okay, in problem D, we have positive integer x. It's called thank you for starting problem with that sentence. Smallest positive integer a has at least 4 divisors. Difference between n and 2 divisors is at least d. What? That's not great. Okay, I think that we have to find smallest prime number after d, and then smallest prime number after like whatever was first prime plus d. But yeah, because we want 4 divisors, right? 4 divisors means like something like p1 times p2, p1, p2, and 1. So p1 should be at least d plus 1, p2 should be at least p1 plus d. Okay, we can find like smallest prime after some point with binary search over array of primes. Once we do sieve, right? Reference sieve, we should be good to go. Okay. What is the max prime number that we would like to find? I think it's around 30,000, but I think it's more than enough. Like we can actually go like for 20,100 or something like that. Just in case, like if I do something stupid, I don't want it to change. 30,000 times 30,000. How big is that? 10 to the fourth times 3. Okay, so we fit into in 32. Okay. First prime plus d, I guess. Okay. No, actually, I don't know. There must be some way, some smart way to filter everything, but I don't know. It's prime. What is primes? I should remove that from my snippets because it's in verbal. Okay, so it's like this. Show everything is prime. Hmm. I don't like these tests. I obviously want more. Because what kind of test is that? Actually, I don't like this as well. It should have just 3. Six 15 is correct. 55 is. What is 55? Let me see. The difference is 3. So we get 1, 5. And then 5 plus 3 equals 8. And the first prime after 8 is 11. So we get 55. Also, it works for. Okay. And it looks like we don't overflow. Okay. Oh, not input file. Okay. How many there were? I don't like this. But with that many test cases, maybe it's fine. Red destruction, we have okay, whatever you say. We found a useless array A of 2n positive integers. We don't actually need this array, so we decide to show all the elements of A. Okay. Okay. Uh, it appears to be straightforward, like integers are positive. So if we ever end up in a situation where our x is smaller than max, x like decreases, so max should be thrown out first. And because of that, it's straightforward, like we just, no, it's not. No, it's not. You know that one of the elements is max, but what is the other element? Like, how do you know? Are we supposed like to try all numbers? I mean, it should pass, but I actually, will it pass through with one? Huh, it's not trivial. So if we, one of them, I'm trying to restore what is the first value, what is the value of x that we should pick? After we pick x, like we only have one strategy, which sounds like take whatever is max. If there is a complement, so number with such that max plus something equals x, and you throw out this pair. If there's not, then and just ignore. Yeah, but it will work like, no, okay, my current solution works in t times n squared times log n. Sum of n over all test cases won't, but it does not help. It helps. Okay, it helps. Okay. Ooh. I thought there was like smarter way to do it, but apparently there's not. There's not such method. Ray A can have, okay, whatever. Is it included? Let me try and just compile it. Hello? Multi-sets, okay. Excuse me. Oh, is it simply sets? Right. Okay, so now it compiles. Um, hmm. Hmm. Because it's a bit bad. Never mind. So does it matter? I mean, we'll make one extra attempt. We don't care. Okay, so my idea is the following. We'll have a pair so like all possible values for x that make sense at the beginning is like you need to have max. Because if you ignore max, then there's no way that you will get and delete it later because your x will decrease below max. So, and I also copy all the time. I believe it's not a big issue, but I'm not sure. Uh, I don't know what I will put here. I guess x. I print numbers. Okay. Okay. Hmm. It looks like we're printing everything correctly. So now let's actually solve. Says success here. So we'll have an if statement that looks like this. So we want to take max elements, iterator to it. Second, because it's ratio. We also want lower bounds of x minus second it, I believe. Shouldn't erase only one occurrence? Actually, this is exactly that is that I was talking about. If we could not find good element to pair with max, then we have to say like we did not succeed on break. Else, and we don't necessarily need else because there's a break, but whatever. No, not only. Um, I did not copy. Okay, what's on? So, line 45 is not correct. Yeah, I agree. And 88. What do you mean? Yes, 61523. No, yes, 21 4 5. Oh, 311 5 6. But I have 5 5. How on earth do I have 5 5? What? 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 So I did something wrong? There's simply no such number. There's 6. I in place this combination, which should be fine, huh? Or am I supposed like to get the value before I erase? Maybe. Oh, maybe it invalidates. So that okay, it makes perfect sense now. I did not write into here. Yeah, probably iterator invalidation took place. So I have to grab value before I do anything. Before I delete the iterator. Erase. Oh, I have 5 6 and do we have like some? Yeah, you see why the complexity is not high. Like for one case, we have n squared times log n, but n squared times log n, I believe, is a convex function. And because of that, like maximum sum of complexities over all test cases is when like one test case is maximal and all other test cases are like, there are no other test cases. And in this case, 1000 squared times log 1000 is like 10 million, so we should be fine. I hope so. Well, if we are not fine, then we'll have an interesting debug exercise. Multisets are slow, a bit. Okay. Problem D, cleaning. During cleaning the coast, Alice found in piles of stones. I think piles of stones are cool, actually. I used to build some when I was small. Okay. So far, piles of stones, AI stones sounds like an in game, but it's piles on neighboring, okay. Okay, right, correct. I see. Alice is too lazy to remove the stones. Understandable. Have a great day, Alice. Absolutely hilarious. Yeah, I mean, the guy, problem setter, he's from Moscow, I believe, or at least from Russia. He's very funny. I don't know him. I don't know him in person, but I heard some stories. So yeah, that's really funny. Uh, so she asks for help, but she like prohibits us to do some operations. Whatever. We select two neighboring piles and boss on an empty, remove one stone from each of them. Okay. It's impossible. Correct. Superability. I suppose it's like once. Select two neighboring piles and swap them. How is that helpful? Okay. I'm not like immediately sure what we're supposed to do, but it sounds like math problem. Usually we are not bad at math, so we should. Let me just quickly read the next one because you know we are not going to solve this problem. Yeah, so far pretty mathematical contest. I like it. Oh, in the previous problem also. Yeah, I obviously need more readers and printers for arrays, like for sets, for multi-sets, for everything. We'll take care of that before the next contest, right? So far, and I don't think I wanted const. Oh, so they just print yes or no? Okay. Yeah, wait, yeah, I understand what we are talking about now. Yeah, you see we have A1, like A2, A3, AN. And we are only allowed to take like one from this, one from this, one from this, and etc. And you immediately see that the only way to decrease A1 to 0 is you have to take A1 from both. And then you want to take like what? Yeah, let's put it this way. After this operation, we have this array. And we want to subtract B2. Then we remain with something like that. And obviously problems arise when this is smaller than this at any iteration. So we can't subtract that many. What I think about this is the following. No, I actually don't know. I was tempted to say like just start from the beginning, and if you can't do something, then you have to swap these two, or maybe these two, but it becomes like non-trivial. What if you swap these two? Because like, no, actually, can we swap these two? Like, yeah, so something like this. Yeah, something like this is a good example. So the correct idea is to swap these two. Because then you'll have 3, 5, 2, and you'll be able to like decrease everything. But if you swap the first pair, that creates some contradictions, right? You'll end up with 2, 3, 5. After you subtract 2, you get 0, 1, 5, and it's there's no way to deal with it. Okay, also let's think what happens if we have something like this. And then we create a contradiction because we subtract. It's so far so good, but when we subtract, we get 0, 3, 4. Oh, it's not a contradiction. So we don't create contradictions here. Because for a contradiction to arise, this number has to be smaller than it. And when we decrease both of these, like a new contradiction can't rise. It can be removed when we decrease this, but can't rise. Interesting. Okay, I don't know what was that message, but it's okay. I'm actually not sure what to do with that problem. I think we made enough progress in the following sense that we can like at least try to read it, to read E. We again have several test cases. Huh? Okay, so there is a permutation, and we should get identity permutations. Stack two indices such that pj equals I and solve the values. Yeah, obviously, because we create one more fixed point at each iteration. Oh, okay, so we control both permutation, P, and choices. Well, yeah, and the thing about this sum, let's like, it's again convex, so we should aim like for a max possible. Interesting. Huh. Can I get, why did I write it in the template for F? Never mind. Yeah, okay, whatever. What is the purpose of having the same input twice? Huh? Okay. So maximize some of them. And first thing, I think that 8 will be enough. Or 6. I'm thinking what you want. I want, okay, 6 is enough. So it's I, and here we'll have EI. Okay. So let's say 6 goes here, and Robert selects 1, 6. Because he wants to put 6 here. And this value should be very unfortunate. Let's say it's 5. Because then 5 will end up like here. Okay. So after operations of the robot, we have a situation like this. And then it selects 5 to go here. So some value of will appear here, which is very unfortunate. And we'll say like, let's say 4 appears here, right? So first we did that operation. Then we did that operation. Okay, what if we just continue? Hello, excuse me? Our Kavanaugh set is not optimal. Just swap this. I'm suspicious about this solution. Let's see. 2, 3, 1, it's the same example, just the other way around, I believe. Or is it? The value is the same, so we don't necessarily care. Then we swap like this to get. Swap this to and get. So here we spent 1 energy operation, here we spent 2 energy, 3 energy, 4 energy squared, 5 energy squared. So around n cubed over 6. It sounds like a lot. Honestly, like, once operation of cost 5 is done, if it's ever done, why does it say that it takes at most n operations? It makes it on at most n minus 1 operations. More than n minus 1 operations. Come on, people. Come on. Okay, so we want how many seconds, which is this sum. Oh my. I remember the formula, but I don't want to be off by 1 or something like that. So thank you, Wolfram. Okay. Yes, it will be hard. Okay. I will be super accurate for no particular good reason. And -1, I believe, because this ends at 5, right? What is the second number that you want to print? Initial value of P, okay. I think it may be a little bit hard to see, but I want to like have both of them at the same time. Oh, I can do it this way, right? Right, what I was thinking. Next thing that we want to do is M. I have no proof that this is optimal. Don't get me wrong, people. Maybe it's not. Maybe it's not. But I mean, quadratic function is kind of like begs for being like to get 5. Because once we got the distance of n-1, at least one of the endpoints is fixed. So we can't like get another 5. Obviously, it's better to have 5 than not to have 5. I think so. Because like function is convex, right? Number of operation is -1 always. It should be printed on UI. Do you want to print indices or indices? Okay. It's kind of unfortunate, but we'll do it. No idea. Did I copy? I don't remember. 312, 312. Minimum, and then it's more or less the same thing, right? This actually shows that you can print in any order. 3, 2, 2, 3. I have no idea, people. Probably we are terribly wrong. But let's think about it. Yeah, whatever. We can afford it. Nothing breaks, right? I mean, it can't be that simple, right? So it must be wrong because it's too simple. But maybe, no, I don't think it's correct. We are going to fail terribly right now. Like pretest 2 wrong answer. Well, that's huh? Okay, at least we don't get a penalty. Bj equals I. Oh, okay. Do we have to print it in reverse order? I don't understand. Please stop spamming. Honestly, why should I be interested in that? If I solve, or maybe I'm hacking somebody else, so it makes sense. EJ says that PJ equals I. Let's check. P3 in our example should be equal to I. I print 3, says 3 is I. Pj, so P1 is equal to I. And we saw that. Okay. So the order was important. I still don't think it's like, it should be running answer like pretest too. It's already not a good sign. Yeah, okay. So things are not that simple. Okay, didn't work. I guess we basically have to like come back to this part. Maybe we can like optimize number of fours that happen before we actually get to 5. Maybe we'll see about it, think about it later. Okay, it's okay. I mean, it was worth trying because we had no clear ideas about this problem. Hmm. Okay. So here again, like if we know the fixed order, then we can process it in linear time, right? If we don't know, then we have to think. I'm tempted to say like, let's just change in order, try to swap first pair, go to whatever position when we fail, but it won't work, right? What happens if we like actually go to some position when we fail, right? If we change anything after it, like it won't help. So we have to change something on the prefix. Still not very helpful. Okay, we can go from beginning, from the end to the first position when we fail. And then think, like why we failed? Because we need to change something on the prefix, swap something. Actually, can we like swap anything on the prefix? Let me see. Suppose we had like A, B somewhere in the middle. After we subtracted something from A, like if this stays the same, we'll always subtract minus C. So here we have like minus C and B, and it's a failure because it is greater than that, right? What happens if we swap them? So a failure is because A minus C is bigger than B. If we swap them instead, minus B should remain the same. You should have such condition. It's kind of implies from here So the only condition we need to satisfy is b minus c is greater than 0. So b is greater than c, but b plus c is smaller. B is greater than c. B plus c is smaller than a. And c is whatever we ended up on the prefix. It's hard. How good are people solving this problem? I need to know. I hope not to see like thousands of people. Okay. Okay. So actually this is already quite hard for people because they don't know about multiset. Okay. This is not real. Okay. Well, Anton is doing a really good job today. Actually, it was our mistake. Now everything will get slow. Never mind, it happens. Okay, it happens. We should keep thinking about the problems. Okay, one thing you may notice straight away is if sum of all numbers in A is odd, and there is no way to do it because we have the following conditions in place. And therefore we have sum over AI equals to sum over xi. Right? So this is always odd. Oh, this is always even, right? So if this is odd, then we fail. Doesn't guarantee that otherwise we succeed, but it's one possible condition that comes to my mind like straight away. And the second condition that you can immediately infer from here is that sum over A minus 1 to the power of AI equals 0. Like this, hat is A0 minus A1 plus A2 minus etc. And you can clearly see that x's on the right hand side, they just got we have xi with plus sign and xy with minus sign. Something like this. Yeah, this actually helps to identify like all possible positions where it is reasonable to swap, but it's not enough, I think. It may happen so that like current value of that alternating sum is 2, and no matter where you swap, you like decrease it by 2, get to 0. This is not sufficient condition for xy to be positive, you see, unfortunately. Actually, if you take like one number twice, I mean, if you take like A1 and A2 with plus sign, and then we take everything else with minus, we will get 2x1, and it should be positive. Yeah, so far I'm inclined to just compute alternating sums. It should be suffix. I believe we actually can like restore alternating suffix sums from alternating prefix sums, but I'm a bit too lazy. And then we'll get rid of like 3 reverses. It does not matter because reverses all we know. Oh, it's actually hard, I don't know. Let's pause it here for a little bit. Actually, why are we doing this? Yeah, let me explain what I mean. I think we want to need this because of the following. What if we simply restore vector x like as is, right? So also x n minus 1 equals a n minus 1. X n minus 2. Oh, it's complicated. So xi, right? Xi is ai minus xi minus 1 most of the time. Right? Of this x does not have to be good for ai, right? for a n minus 1. But what is my idea? Like if we swap AI and AI plus 1, right? What will happen? What will happen? First time when we use AI is here, right? So we have such condition and such condition. So here, like new xi will become AI plus 1 minus xi minus 1, right? Here new yi plus 1 will become this minus this minus new yi, right? If we substitute it here, we'll see that we have such condition. And if we substitute this here, we'll see that we have such condition. Everything like in front of us will change by the difference between these two numbers. I believe everything like in front of us will change by this difference. Some will change to like minus, some will change like to plus. And here I actually think like we can add like one more, but it's fictitious, right? And we want last to be 0. Like all odd positions will increase by delta, all even positions will decrease by delta. We want everything to become positive, so we're interested in like a max odd min even on suffix. And once everything is positive, we are done. Right? And also, oh, we can just like check anything, right? Okay. Whew. Okay, okay. X even X. Do we care? Do we care? Okay. I want to find first time when X is negative, because if we don't change anything like up to this point, then we are in trouble. What do we want to find? Well, I will return bool, which corresponds to value smaller than 0. I think this is what we want. Some hard. It's hard. We actually had the in, but let's override just in case. Then I'll do it like this. Okay. So this is actually like the value that we are interested in. Oh, but we can't say it. Okay. Hmm. Change AI and AI plus one. Okay, these indices are obviously wrong. We'll figure them out later. Also not sad, but multi-sets. I need to include sets into my template. We need everything including first value or everything not including first negative value. First negative value is xi, then changing AI and AI plus one will help. It sounds like we want it not inclusive. Okay. Does it make sense to change, like if there are no negative values, then we just check out this thing? Okay. Uh, we're actually not interested in like sets. We're interested in prefix and suffix maximums and minimums of odd and even lengths. So we could like live with arrays with two numbers, four numbers. But we also have to initialize them with like okay. left and one. This. And one same thing for even. And then for max. We have max. Why are we interested in max rather than mass? I think we're only interested in minimum value rate. Sounds like we are only interested in minimum values. And I will need to add this like that. Also true. Else I think we need to have so we don't need this. We also won't need our first if statement, I think so. This is relevant. We just, at the beginning, we try to restore array x as is. Then we find first negative value. It may happen that it's like end value. It's okay for us. And I'm suspicious about this code because we have to be very careful. See, it always outputs null. Potentially the problem is like this. And it's one of the, I don't know how many possible problems. Unfortunate. Oh, there's also like a thing when, okay. And there are also cases when we, let me just be very explicit and put everything here. So we should at least answer positively arrays that are good from the start. Should see array x printed. So 110. Right, 110. We subtract one from this, we subtract one from this, and then we don't subtract anything from the last. Here we subtract one, then we subtract 0, then we subtract 2. It says it's not good. Why is it not good? Because it finds like right is rightmost, right? So here I say, like, if we have negative values, then all of them should be on the suffix, because our changes did not change anything on the prefix. This corresponds to having like suffix. Included from the beginning. Possible way to debug this. So here right is 3. All suffix min is infinity. Even suffix min is this. Right, so if it is and, then it makes sense to do this. Because if we then go to like this, and it will be just terrible. The right position is at most. I guess I have to do this. Because I want right +1 to be a valid position. Right is 3. Why right is 3? Because I need minimum. Here right is 1. Alt suffix min. Alt suffix min is equal to this. Even suffix min is equal to 2. So 1 corresponds to position pointing at 0. Right? So indeed we have like 1 here, 2, and it says no. And we should start processing from this point onwards. This is exactly these conditions should be fine. Why? Okay. Still no. Okay. Here delta equals -1 because we are trying to swap these two, or why? Right is here. Because these are 1 and 2. Okay. Now actually, is delta like this, or the delta is different? Is delta twice as high? Yeah, because we changed from one to the other completely, like, okay. And it also appears that we need to check conditions by hand. Actually, everyone after, let us see, like, let's see. Hope we can debug it on time. It's kind of tricky. Here, delta equals -2. Okay. Even suffix min. So here it should like stop. Okay. Here we have 2, 2, 2, 1, 3. So 2, 0, 2, minus 1 and 4. Right equals 3. So this position. Okay, 3, like infinity and 4. Delta equals minus 4. We swap and it's again a fit. Okay. Here we have 27, okay, minus 200, okay. 1800, okay, 12. Right, should be 1, so this position. Because if we try changing here, this won't change. Suffix min turns out to be 120, okay. Even is 400. Delta is 600 with such params. Why is delta 600? Because difference between two of these two is 600. It's too much. Okay. Okay. Yeah, if we change these two, then first will become actually even smaller. By the way, should we include like this first condition into here? And x left, which we call something like that should here left is odd. It makes sense to be like this, and here, okay, I'm not sure, people. No, actually, so this was wrong because so here delta equals 400. It's when we swap first two. Alt suffix min. Okay, so alt suffix min is negative. It's at least minus 20 per 100, right? So minus 200. I think we need more debug, unfortunately. And this is hard. On the other hand, if we end up solving it, I will be satisfied somewhat. Okay, so here left equals 1, delta is 600. Between these two, it's not. Left is 1, so we go here. We should check that odd suffix min is at least minus delta. It's true. Why? Because odd suffix mins will increase, I think so. If left is 0, delta is 400, odd suffix min is minus 200. So if left here, odd suffix min should be at least minus delta, right? Means that our conditions here are wrong, I guess. I have no idea, to be honest with you. Like answers are correct. Some of them are unnecessary. What am I printing actually? Huh? Or print array x. But it's very hand-wavy, so some of these conditions may need to change. For example, I have no idea, like, these two seem correct. This also seems correct, I guess. Let's think about it. We know that even suffix means will increase by delt, right? We know that this is n minus 1. So we can check in the following way. We first check if n is odd and n minus 1 is even, and this should be minus delta. Otherwise, it should be plus delta. Here we have the same thing in reverse. Okay, this sounds more like it. Here, x left, all will only x left change. Yeah, because from x left plus 1, like everything changes by delta, and x left changes by delta over 2. It's not safe, I think. Basically, spam 6040 everywhere. I don't know what's the purpose of having 64 for template. What do you mean? Is it because distance returns like... Oh, okay, now the only thing I'm not sure is the sign here. Left is even, so sounds reasonable, right? I don't know. I don't know, people. It's okay. Oof. Here must be a better way. However, we're like, okay, so f is not solvable, basically at this point. I mean, okay. Okay, maybe some stupid bug, he will fix it soon. There should be a way to do it better. What is this way, however? Okay. Okay. What is this way? What is this way? We don't have all that much time. Actually, I want. No what? No what? No, no, no. Let's add you to friends so that we can see what you solved. Okay, so we are basically, no, he has more time. He may solve this problem. Okay. Yeah, unfortunate. Rabbit hole. Oh, so maybe something recursive is actually bad. Okay, let's say we want to make a swap of length 4 first. Can we do it? Not a problem. Uh, no, not one, but something different. Four. Let's see. So basically, first we swap these two. It's length 4. We end up with 6, 5, 4. We swap these two is length 5 swap. But then this is length 3 swap. We are not getting any better. And anything stupid. Like we are super safe here, I think. 10 to the 5th to cube. Why not? Actually, this unlikely will show us any information. Let's know. This is basically this part. Okay. Did we got any? Did we get any error? No, okay, no errors. Yeah, because at first we got like something was wrong with the our performance. Here it's 5, here it's 14. We swap 4 and 3. After, wait a second. To we swap 3 and 1, 2 becomes here. PG equals I. PG equals I. This number is huge, but it's like not much. possible. I don't understand. Like, if you want to make very long swaps, let's think about it. So you have numbers from 1 to 6, right? You want to make that swap because it costs a lot. You want to make that swap because it costs a lot. And you want to make that swap because it costs a lot. Here's 4, 4, 5. And true prices are 25 and 16, 16. If you make 3 swaps and 4 numbers, okay, so let's say there was a 5, there was a 6, there was 1, and there was 2. 5, 1, 6, 2. You swap these two because you want to place 2 on its place. You swap these two because you want to place 5 on its place. Then you swap all the way 6 with 1. You get 1, 2, something 5, 6. But here it's most 1. What you get is squared, 16 squared. Oh, 25 plus 16 plus 16, 32, plus 25, 57, 58. And this is better, this is better, okay. Okay. How much time do we have left? 8 minutes. Impossible. Let's try it. This is wrong. PJ should be okay, whatever. Plus 1 with R, L with R minus 1, R. We'll reorder them later. This is always correct, okay. This is still may turn out to be not optimal. What is the output format? Oh my god. Oh my, why do I need to print that many things? Hmm. Like this, right? Uh, and, mm, no, this never happens. Does it happen? Never happens. Does it happen? +2 or R or -1 L. Uh, uh, man, I mean, we still don't know if it's correct in the first place, right? So it should not be also disappointing if it doesn't succeed. But it will be. I mean, it will be very disappointing. Please don't do that. What? What is wrong? What went wrong? I didn't understand. Something broke. Oh, bro. Whenever we have numbers, it's we are running out of time like already. Where? For 6, the answer is 58, but I don't think it's correct. Now let's go through the 3, 1, because first is 3. You say 2. What happened here? It's not correct. One of these two should be incremented. Oh, damn it. One of these two should be incremented, another should not. You only care about the case with 4. 3, 4. How? How? This is correct. This is correct. This is correct. I don't understand. Are we putting wrong numbers in? This means that we swap R. R plus 1 should be swapped twice. Oh, I mean, like we're restoring it wrong. I mean, never mind. Where? Is it? Did we made it? No? No, we did not make it. Okay. Oh, we can't submit in practice. So. Oh. Okay, I will definitely test this solution. I still have no idea how to prove it, if it's optimal, if it's not, but it's at least better than the previous we had. Let's quickly go to standards until these tests begin. Basically, one person solved F. Okay, Galen Cohen solved problem 5. Congratulations to him. That's cool. Anton solved E like super fast. Okay. Yeah, so some, but again, like some grandmasters solve E, some don't. Okay. Oh, this is minus 50 points. This is why Demoralizer is behind us, because he made one wrong submission. So, otherwise, he was like quicker, slower, quicker. Like here, it does not really matter. Yeah, so he was a bit quicker overall. So far, we don't know about this test. Okay, it will be interesting to upsolve E later on. I will put codes for AD on GitHub. Let's wait for system tests. Hope that we get everything good. Yeah, I need to test this solution. So yeah, thanks for watching. I don't know, maybe. Oh, actually, I don't know. Like, I believe I explained all problems more or less clearly during the contest, so there is like no need to go through problems again. That's it. So, thanks for watching. What can I say? What else can I say? Oh, you can still join our Discord server, actually. I would like to see a discussion. It must be ongoing there. Okay. Let's see if we have anything interesting. Okay, so there's no discussion just yet. And yeah, for terrorism, like my Discord is a bit laggy. Rainbow? Lol. Okay. That's funny. Okay, yeah, I send like you can join our Discord servers. You can also join something like Williams, obviously Ericsson, Galen Cal, actually. Yeah, it's a great community. Like I think whenever you join any of our servers, you eventually support all of us. Just it's kind of good for us, for all of us to see each other grow. So yeah. Again, thanks for watching. Hope this screencast, this commentary helped you a little bit. It's unfortunate we could not solve E, so but we'll definitely try to upsolve it. So yeah, thanks for watching, and I guess see you next time. Bye bye.